Hey class, Mr. Bean here, AP Physics. This is notes for August 30th, 2022. We're with the A3 class and we'll be discussing motion graphs and kinematic equations. All right, so when we start here, we have an object. Okay, all right. Okay, so we're going to consider an object that's moving to the right, and over here is our frame of reference. So FOR is our frame of reference where things going to the right are positive and things going up are positive. Okay, and it's moving to the right, therefore acceleration is going to be positive. Now, it's at rest with an acceleration of 2 meters per second squared. That means each second, its velocity is going to increase by 2 meters per second for a total duration of 5 seconds. Okay. All right. So what would that look like graphically? So if we had a Pascal motion sensor and I had it on acceleration versus time here, we would see that I should get an acceleration. Let me go ahead and use this. Let's use green here. That here's the 2 mark. I should have an acceleration going like this for about well, this should be 5 seconds right here. So it's 5 seconds. Okay, now let me go ahead and erase this here a little bit. So let's do 5 seconds. So here's 5 seconds. Okay. All right. So we're going to go for 5 seconds. Now, for AP test purposes, whenever you have multiple graphs over the same situation, you always want to line up the x-axis because the times will be the same. Okay, so this is what the acceleration will look like. It's constant acceleration for 2 meters per second squared, and it's for 5 seconds. Okay, now if we go down here and suppose I wanted to plot velocity versus time for the same 5 second duration with the same slope. Now, what I recommend is when you give you a blank graph, I personally I dash lines, the horizontal lines like this, and I might even do the vertical lines like this. So when doing this, if you see a blank graph on a test or something, I would kind of like in the background, dash lines, do all the lines. So it's easier to plot. All right, so if I remember from last class, if I have velocity versus time, the slope is the acceleration. Okay, so the acceleration is 2 meters per second squared. So let me go here, write acceleration, we know is 2 meters per second squared. So what that really means is that it's increasing 2 meters per second each second. Okay, so that's what's happening here. So if I go over here, I'll go ahead, maybe I'll use red here or this red color. So I start at 0. So this is my first point right here. And I have to go up 2 over 1, which is like right here, right? Okay, that's 1 second. Up 2 over, so 1, 2, 3, 4 over 1, like right here. Okay, there's 4. Okay, and then up 2 over 1, which is like right here. Okay, and then so there's 1 second, 2 seconds, here's 3 seconds. Now here's 4 seconds. Let me go ahead and kind of draw this out like this here. 1 second, 1, 2, okay, up 2 over 1, up 2 over 1. So over here, I want to go up 2 over 1, which is about right here. That's at 4 seconds. And then this is 5 seconds right here. Make sure I go up 2 over 1, and there we go. So I plotted the points for acceleration of 2 meters per second squared. Okay, and so basically it's a slope. So up 2 over 1, up 2 over 1, up 2 over 1. All right, so now that I have this here, I can very carefully, now I'm going to go ahead and use this tool here. We'll be using Cami a lot. And I like this one here, insert line. So if I go here, I can kind of like draw a line, kind of like best curve fit like that. So there's my best curve fit. Now, obviously it's, recording will end in, okay, 29 seconds. Okay, so I go here and, all right, so here and there we go. So that's what we got here so far. Now, let's go back up here. And so here we have acceleration versus time. Okay. Now, if I were to go like this, what popular shape does this look like?